I grew up a fucking screw up. Got introduced to the game, got an ounce and fucking blew up. Chopping rocks overnight. The nigga Biggie Small trying to turn into the Black Frank White.
Hello and welcome to the practice problems video for the chain rule. Okay, for this question we're going to calculate the partial of g with respect to u and the partial of g partial v. Okay, so here we're given a multivariable function to start off with, our g of x, y, and then we're also given that x and y are both multivariable functions themselves. So this one here is can be considered x of u and v, okay, and this one is y of u and v. So our entire composite function is going to look like g of x of u and v, and then a y of u and v. Okay, so u and v are our independent variables. Okay, so here what we're going to do, we want to compute the dg du, partial g, partial u. So we're going to take this function and take the partial derivative with respect to u. So here we're going to need to implement the chain rule, right? So what we're going to get is partial g, partial x. That's our first primary derivative. Okay, and then if we want to get to u, then we're going to do partial x, partial u. Okay, and then we have plus, we're going to start from g again, so partial g, partial y, partial g, partial y, and then partial y, partial u. Partial y, partial u. And since we only have a two variable function here in both of them, then we only have these two terms as opposed to three terms. Okay, so what we're going to do is figure out each of these partial derivatives that we see in this equation and then just plug them in. Okay, so here we're going to have that partial g partial x. Okay, so let's just write that out. So partial g partial x, if we take the derivative, the partial derivative of this guy with respect to x, we get a negative sign x minus y, and then from the chain rule we take out a 1, which is the coefficient of our x, right? So that's partial g partial x, and then if we look at, so we finished that one, partial x partial u, if we look at this function here, and we take the partial derivative with respect to u, we just pull out that coefficient, which is a 3, okay? And then we have plus, now we're going to take the partial of g with respect to y, so we're going to have the same thing, right? So negative sign x minus y, and now we're going to take out the coefficient of our y, which is a negative 1. Okay, so then we have partial y partial u, that's our last term that we need to find, so that we're going to use this equation here, right, and we're going to differentiate with respect to u, so we're just going to pull out that negative 7 as a coefficient, right? Okay, so let's simplify. We're going to get a negative, let's see, negative 3 sine of x minus y, and then in this term here we have two of the negatives canceled to make a positive, but then we still have that negative 7, so I'll just move that guy to the front, so minus 7 times sine x minus y. Okay, so overall we're going to get that we have a negative 10 sine of x minus y. Okay, so what we want though, this isn't the final step because we want to get it in terms of u and v. Okay, so we'll do that on the next slide. Alright, so we ended up with something that looked like negative 10 sine of x minus y, and we want it in terms of u and v, so we're going to, I'll write this over here, so x of u and v is equal to, let's see, what do we have? So x of u and v is, sorry about that, so we have 3u minus 5v, and a y of u and v, in terms of u and v, is a negative 7u plus 15v, okay? So we're just going to plug those guys in. So we get that this is equal to negative 10 sine of, and then we're going to plug in the 3u minus 5v in for the x, and then we're going to subtract away a negative 7u plus 15v in there, okay? So if we distribute that negative inside, we get negative 10 times sine of 3u minus 5v plus a 7u minus 15v, okay? So this is going to be, this will turn out to be a negative 10, again, sine of 3 plus 7 is a 10u, and minus a 20v, okay? So that's basically it. This is, again, this is our partial g, partial u, okay? So that was the first thing that we were looking for. And now to find our partial g, partial v, okay? Alright, so we'll do that on the next slide. So we're going to start with, so let's see, I'll just rewrite what we had. So g of xy is equal to cosine of cosine of x minus y, and then again our x of u and v is going to be 3u minus 5v, okay, and then our y of u and v is negative 7u plus 15v. Okay, so we're going to start over, and we're going to compute now the partial of g with respect to v, okay? So according to the chain rule, that's going to be, well, I guess I'll just write it here. So this is the partial with respect to v of g of x of u and v, okay, and our y of u and v. Okay, so we have something like that, and according to the chain rule, we get, for starting at g, we're going to have partial g, partial x, okay, and then partial x, partial v now, we want, so partial v, plus, and we're starting over at g here, so partial g, partial y, partial g, partial y, then we're going to make that final leap to the v, so partial y, partial v. Okay, so now let's solve this. So we get that this is equal to partial g, partial x. Again, that's going to be the same thing that we had before. So sine of x minus y times coefficient of x, which is a 1. That's from the inside. And then we have partial x, partial v now. So that is, instead of a 3, now that's a negative 5, because that's our coefficient on the v term. Okay, and then we have plus our other primary derivative, which is negative sine x minus y, and then we have to take out that negative 1 from the coefficient of the y, okay? And then here we have partial y, partial v, so we're going to have a 15 out here instead of that negative 7 from the u. Alright, so this is what we have so far. Now let's simplify a little bit. So we're going to get that this is, these negatives here cancel, so those become positive. So we have a positive 5 sine x minus y, okay? And then this is plus, again, because now we have these two negatives canceled to make a positive. So we have 15 sine of x minus y, okay? So this is going to be a 20 times sine of x minus y, okay? And now again we have to get this in terms of u and v, and we found that x minus y in terms of u and v is a 10u and then minus 20v. We found that in the last portion of the problem, right? So we can just plug that in here. So our final answer for partial g, partial v is going to be a positive 20 sine of 10u minus a 20v. Okay? So that's the second part of our problem. Okay, for this question we're asked to evaluate the partial g, partial theta, evaluated at 2 radical 2, comma pi over 4. So that would be our r and theta. So I'll label that. So this guy is our r and that's our theta, the point that we're evaluating it at the end, where g is a multivariable function of 1 over x plus y squared, and x is given by r sine theta and y is given by r cosine theta. So here we have, this is our outside multivariable function, right? So this is our g of x and y, where x is a function of r and theta, and y is also a function of r and theta. So if we want to find the derivative of this composite function with respect to theta, then we'll just implement the chain rule, right? So we're going to get dg dx partial g partial x, partial theta. So what we did there was jump here and then jump one more time. And then we're going to add that to dg dy this time, right? Because now we're jumping to the second component, and then we're going to jump to that, make the final leap to the theta. Okay, so we just have that, and now we're just going to figure all of these out, all of these partials, plug them in, and then evaluate given the point that we're given. So our r and theta there. Okay, so what is partial g, partial x? So we're going to find that. So partial g, partial x, that would be the derivative of our of this guy, of the partial derivative with respect to x. So another way I'd like to rewrite this is x plus y squared to the negative 1 power. I usually find it easier to do that as opposed to thinking of this as like a quotient rule kind of thing, because that's so lengthy and long. So anyways, I'm going to use the power rule instead. So I'm going to take that, and so this x plus y squared to the negative 1 power. I'm going to bring down that negative 1, and then we have x plus y squared, and then that's now to the negative 2 power. And since we're differentiating with respect to x, we pull out the coefficient, which is just simply a 1, right? So this is going to be a negative 1 over x plus y squared quantity squared. Okay, so we found the partial with respect to x, and now let's do partial with respect to y while we're at it. These are our primary derivatives, right? So now we'll do the same thing. So we're going to start off with this guy in the corner. So if I differentiate with respect to y, we're going to have the same thing, the same like first term, but now we have a 2y taken out from the chain rule. Okay, so our answer for this one is going to be negative 2y over x plus y squared quantity squared. Okay, so keep these in mind. This is the partial of g with respect to x, and this is the partial of g with respect to y. And we'll continue this on the next slide. Okay, so now we're going to do the, so I'll refresh your memory. So we have x equal to r sine theta, and y is equal to r cosine theta. Okay, and so what we're going to do now is find the partial of x with respect to theta, because theta is the variable we want to get to. So if we do that, then we get that r is a constant, right? So we just have r cosine theta, okay? And then partial of y with respect to theta is simply going to be a negative r sine theta, okay? So now we know that we know all of our partials, right? So if we put them all together, what we would get is that we have dg, or partial g partial theta, is equal to, so at first we had partial g partial x partial theta, plus partial g partial y partial theta. So now we're going to replace that. So partial g partial x was negative 1 over x plus y squared quantity squared. Okay, and then our partial x partial theta is sitting right there, right? So that's an r cosine theta. And then we have plus, and partial g partial y is a negative 2y over x plus y squared quantity squared. And then our partial y partial theta is our negative r sine theta. Okay, so this is basically it, and now all we have to do is evaluate it at our point. Okay, so here we see, well, our point was r is equal to 2 radical 2, okay, and theta was equal to pi over 4, but we see here how in our equation, in our final equation that we obtained, we actually have x's and y's still in there, right? So what are we going to do with that? Well, what we can do is actually use these equations here on the top. These are pretty useful, right? So we can figure out what is x when r is 2 radical 2 and theta is pi over 4, and what is y when r is 2 radical 2 times cosine pi over 4. So let's figure that out. So x is equal to, let's say we plug in our point, so then we have that, right? So something like that, and sine pi over 4 is radical 2 over 2. So this is going to turn out to be, sorry I'm squishing that in there. Let's draw a line here to make that a little bit better. Okay, so then we have a 2 radical 2 times a radical 2 over 2. So this is going to turn out to be something, so the 2's can cancel, right? And we get that 2, so the x will just be a 2, okay? And let's do the same thing for y. So if y is equal to 2 radical 2 cosine pi over 4, this is going to be equal to 2 radical 2 times radical 2 over 2, which will turn out also to be a 2. So now we know that both x and y are equal to 2 at the given point, okay? So now all we have to do is plug in all of the values that we have obtained. So r is equal to 2 radical 2, theta is equal to pi over 4, x is equal to 2, and y is also equal to 2. And our formula that we have found is that this dg d theta is equal to a negative, we have negative 1 over x plus y squared, okay, and then that's multiplied times an r cosine theta, okay, and then we have plus a negative 2y over our x plus y squared quantity squared times a negative r sine theta, okay? So now if we plug everything in, we get that dg d theta evaluated at 2 radical 2 pi over 4, which is what we want, right? That's going to be equal to a negative 1 over 2 plus 2 squared and quantity squared, and then r times cosine theta, that's going to be 2 radical 2, and then a cosine pi over 4, plus, and then now we have a negative 2 times, not a y, but y is now a 2, so we're going to plug that guy in. So then on the bottom we also have a bunch of 2's going on, right? And then we have a negative 2 radical 2 times sine pi over 4. Okay, so what are we going to do with this now? We just simplify, right? So this is going to be, this here, we know that to be a 2, okay? And then this term here, that's going to be a 2 as well, except for we have this negative sign. So this will become a negative 2, okay? So now what do we do with that? Let's see where we go. So now we have a negative 1 over what? Now we have 2 plus 4 squared, so that would be a 6 squared on the bottom. Okay, and then we have a 2 being multiplied, plus, and now we have a minus 4 over 6 squared on the bottom, times a negative 2, okay? So now this is just going to be, let's see what we have. So we have a negative 2 over 36, and then this will be a plus 8 over 36, which turns out to be a 6 over 36, a positive 6 over 36, which is a positive 1 over 6. Alright, so that's pretty much it for that problem.
Face me when he drop, take his Glock and I'm Swayze.